going over logs. So the most important thing that you can understand about a logarithm is a log is just an exponent. It's just a different way of writing an exponent, but anytime we deal with one and we're trying to solve one, we want to think about it as an exponent. So exponents and logs are inverses of each other. That's why a log is just an exponent, just a different form. Here is your conversion to get back and forth from a log over to an exponent. So if you look at the two forms, you can see start at the base, counterclockwise loop, finish at the x. If you're trying to get out of the exponent form, start at the base b, counterclockwise loop, and that's how everything gets lined up together. All right, so first one, example 1, convert each expression to the equivalent exponential or log form. So we're just going back and forth between the two forms. So for A, we've got log base b of 5 equals A, and we're being asked to go to the other form, which would be the exponential form. So start at your base b, counterclockwise loop, which is going to give us b raised to the power of A equals 5. So all we're doing is changing forms. We're not evaluating anything, just changing forms. All right, second one. Start at the base. This is log base 3 of 9 equals 2. Start at my base, counterclockwise loop, finish at the 9. So the exponential equivalent would be 3 to the power of 2 equals 9. So just to show you a log is just an exponent, 3 squared equals 9 is true. Third one. This is log base 1/2 of 1/16 equals 4. Start at the base 1/2, counterclockwise loop, 1/2 to the 4th power, so it needs to go in parentheses, equals 1/16. Just going from one form to the other. All right, example 2, it says simplify each of the following without a calculator. So again, a log is just an exponent. So if you're asked to evaluate a log, such as this, without using a calculator, you simply just need to think about it as an exponent. So what goes through our head is start at the base, and then I would go over here to what's on the other side of the equal sign, and then we would finish at the 8. So in our head, we're thinking to answer this question, 2 raised to what power equals 8. So 2 raised to what power is going to give us 8? So if you write it mathematically, that would be 2 to what power is 8? Well, it's 2 raised to the 3rd power, so the answer would be 3. B. So notice for this log, there is no base attached to this log. So there's two types of logs that don't actually have a base written in. One is called the common log, which is this one here. The other is called a natural log. So for a common log, the default base is always 10. So if you don't have a number that's shrunken down kind of in that subscript area, its base will always be a 10. So we've got our base down. 10 to some power has to give us 100. So 10 to what power is 100? Mathematically, that would be 10 to what power equals 100. Now what power is 2, 10 squared, so the answer is 2. All right, I had said there were 2 logs that don't have a base written in, so just we'll call it bonus example C. Or actually, we can't really call it example C because this one has to be done with a calculator. So your other log that doesn't have a base written in is called a natural log. And your natural log is base E. So anytime you see an ln, the base is always an E. So we'll put base equals E. So natural log, ln, always base E. Log with no log, with no base written in, default is 10. If it's anything besides 10, it'll be like the first one here. You'll see a number written there. All right, and then there's your little reminder. Common log is discussed here, base 10. Natural log discussed here, base E. Any others, you'll see it. All right, so now we're going to evaluating with a calculator. So Logs are just exponents. However, if it's not a nice, pretty number like log base 2 of 8, we have to use a calculator to evaluate those. So if we look at this first one here, we're using a calculator that says round to 3 decimal places. So you have a log button on your calculator. You're looking for the button that says LOG. And we just simply type log of 3. And in the calculator that displays, that's the wrong color, 0.4771. So that would round to 477. So we're just pushing buttons here. For B, B says LN. That's not IN, it is LN. This is your natural log. On your calculator, you have a separate natural log button. So we would push the LN button and type in 9, and that gives us 2.1972. So that third one would stay as 7. So be really careful. Make sure you read how to enter if you are having to round in the online homeworks, quizzes, tests. C, log of 1/4. So again, just type this in carefully. Make sure that 1/4 gets put in a set of parentheses. So we use our log button, our LOG button this time, and we get negative 0. It is 6020. So that would be 602. All right, so notice every single one of those examples we just did was either a base 10 LOG or the base E, the LN. So you got to make sure you know what do you do if it's not a base 10 or a base E. So the next formula is your change of base formula. This is for converting any log base to any other log base. So we have a base 10 button log on our calculator, and we have a base E button for our calculator, but we don't have the other buttons. So this is the formula we use in order to evaluate those logs. So main thing you want to notice is what goes what place. The A means it can be any base you'd like it to be. So if we're trying to type it into the calculator, we would want to use a base 10 or a base E. And notice the X is going to go up into the numerator log. The B goes down into the denominator log. The B is shrunken like a subscript. It always goes to the bottom. All right, example 4. Evaluate each of the following using a calculator, round to 3 decimal places. So log base 2 of 5. I don't have a log base 2 button on my calculator, but I can change this to any base I want. So you have 2 choices. You can change it to the log base 10, the common log, or you can change it to a natural log, which is base E. You will get the exact same answer regardless of which one you do. So we'll show both. So let's say you chose to go to the common log, which would be base 10. You've got log over log. Remember, the 5 is going, what I want, purple. The 5 is going to the top log, and the 2 is going to the bottom log. So I would type in log of 5 divided by log of 2. Make sure you get that division bar in between them. Or if you chose a natural log, we would do ln over ln, and the same thing. The 5 is in the numerator log, and the 2 is in the denominator log. So if you check and type both of these into your calculator, you are going to get 2.32, and then it's 19, so that 9 is going to bump it up to 322. All right, B, log base 6 of 8. So same thing. Common log base 10 or natural log base E, does not matter. So we would do log over log, or we would do ln over ln. So once again, the 8 is inside, it's going up. The 6 is subscripted, so it's going down. So the 8 up, 6 down, or if you chose the ln route, the 8 up and the 6 down. So again, type both of these in just to confirm they are the same. Told you it doesn't matter. Then we get 1 point, it's 1, 6, and then it's 0, 5, so that's going to bump it to 161. All right. Next thing we're looking at is graphing logs. So logs are inverses of exponents. So right here you've got a graph of each. The exponential function, it's got that exponential curve that levels off. And then the log function that does not level off. So it kind of looks like it's leveling off here vertically. The exponential function, remember we talked about had a horizontal asymptote. A log function has a vertical asymptote. So it's like a wall that the graph doesn't go through. All right, I couldn't find this picture with everything in there, so I had to draw it in. So if you look at this graph here, notice how all of these bases are bigger than 1. So they're all increasing from left to right. Notice all of these bases that I drew in here to match it up are between 0 and 1. So they're a mirror image, they're decreasing. Nice thing about log graphs, every log has a vertical asymptote, and it's going to depend on the transformations given as to where that asymptote is going to be. But just keep that in mind. It's like the exponent where it's going to level off. It's going to level off vertically along where that asymptote is based on your transformations. All right, so here is your standard transformation form. And again, if you need to review it, it's section 7.2. So before with an exponential function, we were looking at D to locate where it leveled off. Now we are going to be looking for C. C is going to be the key to figure out where we have that vertical wall. All right. Next thing we're going to look at is calculating some values. So first one we're asked for is log of 0. Notice that's common log, so we don't need to do change a base here. If you type log of 0 into your calculator and hit enter, you should see it should say something about error. It should say domain error. There's a lot of variations. That is because, look at your graph up here. 0 is along the y-axis. So if you look at this y-axis, notice nothing from that graph is touching it. That is because it has a vertical asymptote there. You are not allowed to take the log of 0, so it does not exist. So DNE means does not exist. You might also see undefined as your answer. So they mean the same thing. So it does not exist, it's undefined, either one. All right, log of -8, also common log, has no bases written in. So again, go back to the calculator, we hit the log button, we type in -8, close the parentheses, hit enter. And once again, you get that exact same error message. So back to the graph, looking at the graph here, negative x values are over here on the left. There is no graph over there as well. You are not allowed to log 0. You are not allowed to log a negative. So this is also DNE or undefined, whichever you prefer. Third one, natural log of 0. It doesn't matter what kind of log. It doesn't matter what the base of that log is. 0, negative, you cannot do it. Does not exist, undefined. And natural log -2, it doesn't matter the log. You cannot log 0. You cannot log a negative. DNE. All right. So now that we understand why we cannot take those, let's go get a graph sketch. So notice our graph is only going to be on one side of that dashed vertical line, depending on the transformations that we're given. All right, so graphing each function below. So first thing you want to note is the base. So here, this is our base. So our base is 3. So what that means as far as our graph goes, it is increasing unless we have a transformation that's going to change it. So that is going to swing up and to the right based on the base given. If we look at the function f, there are no other transformation, or there are no transformations whatsoever. So to sketch this graph, I know that dashed vertical line is going to be along x equals 0. So since there are no transformations, we're going to put a note here. And it's not necessarily the transformations, it's no left, right, shift. Left/right, shift. So what that means is that our function is going to level off vertically at 0. So it's going to levels off at x equals 0. We have to have a left or right shift for it to change where it's going to level off. So as far as our graph goes, let me get a quick x and y axis. Like I said, you'll be drawing these in the computer or picking multiple choice, so you don't have to draw X and Y axes, but I do. So we said leveling off at X equals 0. And again, you don't draw these in the online, in my math lab, but I am going to draw it just because it gives you a better visual of the leveling off. So we said it is increasing, leveling off at 0. So from close to that dashed line, it's just going to swing up. Oops, that's not very good. Let me try to rotate this a little bit. It's going to swing up and off to the right. Right. Next one. So base first. Base here. 1/3. And 1/3 is between 0 and 1. So when your base is between 0 and 1, our graph is decreasing. So ours is going to look like this unless there's a transformation that's going to make it change direction, like a reflection on the X or Y axis. So looking at this function, there is nothing else in there. There are no transformations at all. So it's going to be the same as the last one. This one's going to levels off at X equals 0 because there was no left or right shift. So again, X, Y axis. I'm gonna be lazy for a minute. Let's see if I can copy paste. Copy, paste, look at that. All right, so we're leveling off in the same place. However, because the base was between 0 and 1, we are swinging down left to right. So ours is gonna do something like this time. See? This is an LN. Remember, LN is base E. If you don't know or you've forgotten, you can always go to a calculator and type in E. E is 2.7-ish, so it is bigger than 1. So E is always bigger than 1. So that means this is going to be increasing from left to right. So this is going to be increasing unless there's a transformation that's going to change it. So right now we think it's going to look like this. Let me look at our transformations. All right, this time we have transformations going on. So first thing here, this outside, remember that negative outside is a reflection across the x-axis. So what that means is our function is not going to be increasing, it's going to be flipped across that x-axis, which means it is now decreasing. So we're going to flip to decreasing. So now ours is going to look like this. Because of the reflection, we have to flip it over. Next thing, next transformation, inside here we have a +4. Remember that is C minus right plus left. So we are going left 4 units. So this function is going to level off at X equals left 4 would be -4. So X, Y axis, go here, and we'll go here. All right, -4, again, you don't need to draw these lines in on the online homework, but because I don't have a little animator, I do think it helps. 2, 3, so -4 is going to be here. And that's supposed to be dashed. Oops, let's change it, make it dashed like it's supposed to be. It's not actually part of the graph. 1, 2, 3, there we go. All right, so ours is going to level off here. And remember, it is decreasing. So we are swinging close to it at the top and down and over. All right, D. Got a lot going on here. All right, so first thing, base first. There's no base written in, so I'm going to go put a 10 in. So the base is 10, and 10 is bigger than 1. So right now we're increasing unless there's a transformation that's going to change that. All right, if we look left to right, so the first transformation, that 2, remember the 2 is, I'm just going to label them. Let's go, yeah, we'll figure it out. All right, I'm just going to go down here. So the 2, that is your vertical stretch by a factor of 2. So you're vertically stretching the graph out by a factor of 2 because the 2 is outside being multiplied. Okay. Factor of 2. The next one, so I'm just going left to right. Remember, the 10 is a base. It is not a transformation. So the next one is going to be that negative. So the negative inside is a reflection on the y-axis. So a reflection on y is different from x. So instead of flipping it top to bottom, you're going to flip it left to right. So our increasing base e log looks something like this relative to where that dashed line was. Reflecting it on the y-axis, what this means is it's going to be on the left side of that level off. So instead of graphing it on the right, like all the logs where we looked at earlier, it's going to be on the left side now. So ours relative to this line here, it's going to swing like this, which is an exact mirror image of this graph up here. It's just folded over sideways rather than top to bottom. All right, and then we have our last one. I need a new color. So going in here, just come down like this. Minus, so that means we are going right to. So that's going to tell us our level off. It's going to be at the x value. Right to is x equals positive 2. All right, x, y axis. We'll go 1, maybe. And we'll go here. All right, leveling off at 2. So again, you don't have to draw these in the online homework. I'm going to draw it in so we can see it. And then we are on the right side, swinging up and off. So let's see. Something like that. Actually, that kind of looks weird. Let's go. There we go. That one's a little bit prettier. Next, so a little bit of word problems. There's a you tried at the bottom. All right, example 7. Students in an accounting class took a final exam and then took equivalent forms of that exam at monthly intervals thereafter. That sounds terrible. The average score, S of t, as a percent after t months was found to be given by the function S of t equals 78 minus 15 times the log base 10, see that no base there, of t plus 1, where t is greater than or equal to 0. And then we're asked some questions. So let's see. What was the average score when the students initially took a test? Initially took the test. So again, you got to figure out X or Y. What do you know? What are you looking for? So if it's helpful, go highlight, mark something. So there's our X. Remember the inside is your X variable here. So we know this is going to be X. So X is T, which is time, and it's measured in months. And then it says S of t is something. Oh, right there. S of t is the average score in a percent. So always know what your variables and units are. All right, so if we go read this problem, what was the average score? What was the average score? That means find y, because we don't know what y is, when the students initially took the test. So initially, it's an important word. You want to make sure you understand what it means. That means when everything first started. So in this case, when t equals 0. No time has gone by. They took it and then started counting time. So we're being asked to plug in 0 for t. All right. So S of 0, I had to get where I could see this function. 78 minus 15 times the log of 0 plus 1. And then we go to our calculator and we carefully type that in and we get the nice pretty number 78. Okay. So it says, what was the average score? So then go answer the question. There's no rounding needed here since it was a pretty number. So the average score is 78%. Don't forget that percent symbol. Remember, you do need units when you're dealing with a word problem. All right, next one. What was the average score after 4 months? Then after 2 years, give your answer to 3 decimal places. So let's see. What was the average score after 4 months? 4 months. That is your x variable or your t variable. That is time. So we're plugging in 4 for t now. All right, so S of 4 equals 78 minus 15. I'm going to run out of room. Log of, log is t plus 1. Yes, t plus 1. So it's going to be 4 plus 1. And then we go to our calculator, push some buttons. So from the calculator, we get 67.515 because there's a whole lot of numbers there. So I'm going to go reread. Give your answer to 3 decimal places. So this is the average score after 4 months. It's 67. I should stop moving. 67 point. It's 5.1 and then it's 5.4. So that's going to stay a 5%. So after 4 months, 67, 68-ish average. So that's not bad to me. All right, and then there was a second question. So I'm just going to put a little line here. All right, so then it says after 2 years. So you need to be very careful with this, with the word problems. You got to catch the unit change here. It is not x or t equals 2. It is x or t equals 2 times the 12 months in a year, which is 24. So we're actually plugging in 24 for t. So S of 24 is 78 minus 15 times the log of 24 plus 1. And then we push some more buttons on our calculator carefully. And what we get is 57.030. And then we go read to answer, make sure we answer it. Sometimes it will say nearest whole number. Sometimes it will say 3 decimal places. It says 3 decimal places. So the average score after this time is going to be 57 point. It's 0.3 and then it's 0.8. So that 8 is going to bump the 0 up to a 1. And then percent. Don't forget your units. Give me the mark down there. All right. Whoops. So the rest are you try it problems. I'm trying to zoom where you can see the whole question. There we go. So feel free to try those and then check out the completed notes in Canvas.